So we have two friends who are big sports fans and they're watching baseball. And they think that the batting average of ACC East is less than the ACC West. So they want to test their theory. So they take a sample of size 50 from ACC East, for which the average is this, and for 40, sample of size 40 from ACC West, and the sample average is this. But the population standard deviations are known, and they're given as such and such. So we have to test the claim that ACC East have a lower score on average than ACC West, and level of significance is 0.01. Obviously, this is a two populations problem. It's a means problem where sigma 1, sigma 2 are known, and it's a chapter 8 problem. So we start with the hypotheses. Now in hypothesis, because it's two population and it's a means problem, we should be looking at mu1 minus mu2. So mu1 is for SEC East, and we are claiming they are lower than SEC West. So that means mu1 is lower than mu2. So HA should be mu1 minus mu2 less than 0. That's what we're testing. And H0 should be mu1 minus mu2 equal to 0. That means there is no difference. So our test statistic is z equals x1 bar minus x2 bar divided by square root of sigma 1 squared by n1 plus sigma 2 squared by n2. All the numbers are given here. If you plug them in, you get minus 1.33. Next step, the rejection region. So because it's a z-test, first I shall draw a z-curve. Now it's a one's left tail test. It's a left tail test. So I shall draw the left tail. How fat should be my tail? My tail should be 0.01 fat. Okay, so area left of ZC is 0.01. If you look that up in the Z table, then you shall find that ZC is minus 2.325. When do we reject? If Z is less than ZC, that means the left tail, then you reject H0. If Z is less than ZC, you reject H0. Does that happen for us? No. For us, Z is minus 1.33, which is actually bigger than minus 2.325. So we fail to reject H0. Fail to reject H0 means SEC, like we have failed to prove that SEC East is lower than SEC West. So there is no significant difference between the two teams. That's our conclusion.